Hello everybody. This is Class 8 of Technical Tools for Technical Writers. This will be on localization, so let's get started. There's a nice view of Cannon Beach in beautiful Oregon. Let's just get right into it. So today we're going to talk about localization. Localization is going to be in two parts. This is going to be the introductory part, and then we'll have some advanced stuff next week. Localization sometimes goes wrong. This is a familiar, iconic Kentucky Fried Chicken saying, or what do they call that catchphrase? Finger licking good. And it was translated into the Chinese market into something of an unfortunate translation. We see that a lot. So we are here in Class 8. Last week in Class 7, we did the midterm exam and the D2 deliverable. Hopefully everybody's had a chance to turn that in. Today, week 8, November 19, we're going to talk about translations, translation memory systems, mostly XLIF, but we'll also talk about TMX, TBX, and the tool we'll be using in this class which is Swordfish. And then looking ahead to next week, which will be an asynchronous class on Zoom, we will be looking at localization in practice, round-tripping data with Swordfish. So why does localization matter? Well, it has to do with the world we live in. We now more than ever live in a very global world, and global is of or relating to the entire world. And the world, of course, has been characterized by many people over the years. Shakespeare, all the world's a stage, all the men and women merely players. And then it was upgraded by a band called Rush. All the world's indeed a stage, and we are merely players, performers and portrayers, each other's audience outside the gilded cage. So the global reality is that it is nearly impossible to do business in this age in just one language. The communication reality is that communication, whether it be websites, email campaigns, manuals, brochures, data sheets, marketing safety bulletins, or whatever, must be robust. And the machinery that creates these communications is elegant but complex, powerful but complicated. So the translation reality is that today's elegant but complex, powerful but complicated tools are seldom optimized for translation. So speaking of tools, how did we get here? Where are we and where are we going with regard to translation and communication? Started with cave paint, we went through hammers and chisels, we moved into paper and ink and printing presses, typewriters, and then came computers and printers. And then with computers and printers came word processors and databases. All of that's sort of the backdrop, at least the preceding two bullets, for where we are today, which is still some desktop publishing, but we're gradually moving into content management systems. And that is what is going to help us with this tricky, complicated localization and translation process. So today we'll be talking about XLIF and translation memory. And we'll be talking about more open standards. The theme for this class has been all around open standards, and open standards matter. We know why. Everybody got that question right in the last quiz, and I assume in the midterm exam. But the open standards we're going to move to now, of course, we know that XML is the underlying open standard for all localization, translation, open standards. But those localization, translation, open standards that we will be looking at are XLIF, XML Localization Interchange File Format, TMX, Translation Memory Exchange, and TBX. There are some other open standards that would be worth mentioning. SRX is all about segmentation, GMX, and ITS. Just be aware that they exist. For an introductory class, we really don't need to go into those. But the first three we will for sure. So why do open standards matter in localization and translation? Well, it's because it's hard. Translation can be difficult or easy, more often difficult. The paradox in what we've been looking at, we looked at XML to start off with, and then we looked at well-formed and valid, and then we moved into a specific open standard in XML called XHTML, which warmed us up for the work that we did in DITA. And the paradox is that DITA's strength is its ability to harness many topics for a variety of outputs. And we saw that. With concepts, references, and tasks and DITA maps, we can literally have millions of topics on a website that work cohesively together. And that's because of the content management systems and the open standard DITA. The difficulty for DITA and for localization service is all of those files. So for these files are just for a simple project in the DITA Open Toolkit, but looking at them on the file system, just to do this simple project would be a lot of work if we were going to open every one of those files and translate them. That's a lot of overhead. Now, if you look at something more realistic, like the files that it would take to create a user manual, now we're talking about thousands of files. So there's an ill-advised translation workflow that sometimes is used that involves translating topics and maps in some cases without XLIF. And it looks kind of like this. So if we go back to this slide and we say that there are about 350 topics in this user manual, and we're going to try to use it with this ill-advised workflow that does not include XLIF, those 350 DITA files would be sent to the localization service provider. So you can see the blue there, that's the domain of the content owner, and then the yellow is the domain of the localization service provider. So step one would be to collect all of the DITA topics, SVG, images, and from the component content management system, and throw them, step two, over the wall, all 350 to the localization service provider. They would need, all of the localization service providers would need to test all 350 of those files one at a time. They would then maybe transform the files into XLIF. Option A would be XLIF would be opened in a computer-aided translation tool, or option B would be the DITA files are opened one by one in the computer-assisted translation tool, CAT tool, computer-aided translation. They would leverage TM in step 6. They would translate in the computer-aided translation tool all 350 topics. Had they converted it to XLIF, then the XLIF would be transformed by them back into its initial format, in this case being DITA. The translation would need in-house review, in-context review. All of these steps 3 through 9 are done by the localization service provider. And then they throw them back over the wall. And the translated content is then approved by the domain content owner and collected and translated into the DITA topics and SVG files in the component content management system. Why is that bad? It's very risky. It's expensive. It's time consuming. The quality can suffer. There can be inconsistent translations. The file conversions can misfire, and you would be a victim of vendor lock-in. So what's the advised workflow? Translation with XLIF, which we characterize as the best practice. So if we go back into that paradox, about what's difficult about DITA, the strategy then would be to take advantage of the DITA map files in order to manage the many topics and create an XML style sheet language transformation to read the map file and convert each of the referenced files into a single XLIF file. We didn't go over XSLT in this class, but just know that it's part of one of the family of XML standards that does transformations. That's the ideal tool within the DITA Open Toolkit and the tool that I wrote, the DITA XLIF round trip tool, to take advantage or to leverage the map files in order to get a manageable XLIF file. So let's look at that preferred workflow. You notice that the blue part, the domain content owner, most of the steps are there, but they're done not manually, but by the component content management system. So we have our starting point is that collection of DITA topics and SVG files in the component content management system. We gather and verify them in the component content management system. The component content management system, step 3 there, automates the transform into XLIF, and then the XLIF file, single file, is sent to the localization service provider. The localization service provider simply opens it in a CAT tool, and we'll show an example of that later in this recording. Actually, it'll be a separate recording, but we'll show an example of that. We'll leverage translation, the domain in the LSP, the LSP's domain will leverage the translation memory. They'll probably reference a TBX file, a term-based exchange file, to make sure that all of the terms are correct. They'll translate it in the CAT tool. This, by the way, Swordfish is a computer-aided translation tool, this tool that we're going to be using in this class. Then the translated XLIF file is returned, and then the content management system automatically transforms that back into DITA. The translated content is approved, and then we end up step 11 with a collection of translated DITA topics and SVG images that we can then press the HTML button or the PDF button or the online help button to create the output that we want. So all of that risk that we saw in the ill-advised workflow not using XLIF is mitigated using XLIF. Our expenses are lower, we save time, the quality is increased, we have consistent translation, we don't have any conversion misfires, and we're not locked into a single vendor. We could take that XLIF file and hand it to vendor A, vendor B, and vendor C, and because it's an open standard, XLIF is an open standard, there are no proprietary steps. So we talked about XLIF. What is XLIF? XLIF is the XML localization interchange file format. It's an OASIS open standard for the exchange of localization and translation content. Translation tools like Swordfish use XLIF as their native file format. Translators, the people who do the translation, know XLIF. 1.2 was passed as an OASIS specification in February of 2008. My signature is on it because I was the co-chair back then. It consisted of the specification and the schema. And then XLIF 2.0 was passed August 14th, where I was the chair of the XLIF technical committee, and my signature is on that one as well. I'm no longer on the XLIF technical committee, but I served a good long time on it and have some very fond memories. But that's not why I love XLIF. XLIF is just the right tool, the right open standard for this particular job. So how does XLIF work? It has a translation file, a model, XLIF translation model that it follows. It supports the extract and merge paradigm, an established model for efficient translation. So we start with our source DITA project. We extract the localizable text and format information into a single XLIF file. We open that XLIF file with our translation tool, our computer-aided translation tool. The one we're going to look at is Swordfish. Translate the text, save that translated XLIF file into a bilingual file now. The source is all in the source language and the targets are on the target language. We'll show you how that works in a second here. convert the XLIF file into its original format, and we have a translated data project. So the workflow, to get a little bit more specific, the graphic files linked to the XML documents, in this case, are SVG, and we have our source language. This is just to show that it doesn't have to be DITA. It could be DocBook or any language at all. And then we transform those into XLIF. We have a single XLIF document that has the document and the images. The localization service provider translates that XLIF, the translated document, and which now has the translated strings for the document, and the SVG file is then transformed back into its original format, and we have all of the information in the language we need to do our publications. So how does XLIF work specifically? It's simple. It isolates the translatable text into translation units. We have a segment that has a source and a target. We retain the source document structure either externally or internally via the skeleton, or internally with group elements. So that's XLIF. We talked about a couple of other open standards that really matter in this effort. First one we'll talk about is translation memory and TMX. Translation memory enables the translation of segments, sentences, paragraphs, or phrases of documents by searching for single segments in a collection and suggesting matches that are found. And this quote comes right out of that XML localization reuse translation with TM and TMX in the Max Programs website, which Max Programs is the tool that we use. Max Programs is the company that makes Swordfish. And that quote in that article says that a translation memory system remembers translations that have been typed by a human translator. When the translator needs to work with a similar text, the system offers the previously saved version. This can save a lot of time when translator works with repetitive texts, such as technical manuals, and can also help to achieve terminological consistency. Little typo there. And translation memory is found in the database. So this is what a translation memory, a TMX file, looks like. We've got a segment there, and the source language in this case is English, and it says the Clash was founded in London in 1976, considered to be one of the most influential early punk bands alongside other bands such as the Ramones and the Sex Pistols. And then we have the German translation there in green. Then the next segment is Nirvana was an American grunge band from Aberdeen in the state of Washington, translated to German in the green segment there. Soundgarden is an American grunge band from Seattle, and that's translated in that to German in the green. That's what TMX files look like. We also have terms. Terms are important to get right, and to use that we use TBX, Term-Based Exchange. TBX is a structured XML standard for exchanging terminology across tools and organizations. It was designed for terminology management and localization workflows. It stores concepts, terms, definitions, parts of speech, and metadata. It supports multilingual term bases for consistent global communication. It ensures that translators use the correct approved terms. It's a tool-neutral format that works with the computer-aided translation tools like Swordfish, content management systems, and localization service providers. It's often used alongside XLIF and TMX in the translation pipeline. TBX helps to ensure terminology consistency by providing a standard way to represent and share terms across teams, languages, and tools. And this is what a TBX file looks like. So we have a term, which is concert, and its description is that it's a musical event and it's a live performance, typically of music before an audience. We also have this translated term here. That's really not necessary because TMX takes care of that. This is just to show that we do have a mechanism in TBX to store that translated term. So the narrative arc, interesting title, the narrative arc, I like it. Here's what we've said so far. Localization is a global necessity. Technical content has massive amounts of topics. It must be automated. DITA is great for structuring, but bad for translators because there's just too many files. XLIF solves that problem by putting all of those files into one master file. TMX, translation memory, stores previous translations. TBX standardizes terminology across languages. Swordfish then is a CAT tool that we're going to look at in just a second here that ties these standards together. And then in our D3 project, you'll get to practice the entire workflow. So just a couple more slides, and then I'm going to switch to my PC to actually do the demonstration of Swordfish and to do the step-by-step guide how to do D3. Seems like separating these slides, these two recordings makes sense in that regard. So the Swordfish demo that I'm about to do, when I switch over to my PC, you'll get to look at this firsthand, but basically XLIF looks like just a collection of segments in Swordfish. On the left-hand side there where it says source, in this case it's in English, and this is I think a manual for using one of the Max program tools called Fluenta. And then on the right-hand side, we see that the translator has begun to translate that into Spanish. We have some segments that are represented by the green numbers there. On the right-hand side, you see that we're using a translation memory, and then it has a 58% match rate. We're not using a glossary in this case, and there's a machine translation associated with it called DeepL. So let's stop here, and if you have any questions about Class 8, let me know, and I'm going to switch over now to the Windows PC, and I'm going to demonstrate Swordfish and go step by step for each step to do the D3 project. Thank you.